certification. Now, we'll also talk about the 12-week framework on for you to learn Kubernetes like an expert, and not just Kubernetes, but also Docker with that, or the container technology behind the Docker and container technologies. So this step-by-step framework, we'll talk about that as well. Now, with this, you will also need to do a lot of hands-on. So we'll talk about all these hands-on that you should be doing in order to not only learn Docker Kubernetes, but also get this certified or get this certification. Now, towards end, I'm going to also open up a step-by-step comprehensive 12-week program where we talk about right from complete beginner concepts, architecture, storage, networking, high availability, scheduling, performance tuning, security, Docker compose, administration part, everything that you need to become a certified Kubernetes administrator, including labs, hands-on labs, as well as the comprehensive program. Now, if you like today's session, if you think want to go deep and you want to learn all this quickly, we'll open it up towards end. But there are only 25 seats with Mamta on this program. Now, if you do decide to do the program, which I'll highly appreciate, you will see the value in a minute or in next 30 minutes or so. But if you do decide to the program, then there is a free gift for only first time action takers. That's only while you are in that. So it's going to be very interesting. I'll open it up, or I'll tell you about this a little bit later. Now, all this, like my various other programs, are all basically proven programs which actually works and they actually give results. So these are some of the success stories from our other students or from previous batches, like other students like you, who not only have got jobs after doing these programs, but also have done the certification. Or a lot of guys don't look for certification, they just look for or only for the job, but they also are implementing these things but are confused, and they need someone to help them on their journey, or they need someone to give that confidence and someone to be there to ask these questions. So success stories to inspire you. Now, this is not one, two, but we have hundreds and hundreds of success stories who are like you, who have taken action and have got a result. We'll talk about all these a little bit later, but this is to tell you that what you're going to learn today, it's all possible, it's all doable, and there are a lot of other students who have done it before you and have got results as well. Now, not only students, but we also run these workshops with corporate customers. And these are some of our handful customers for whom we have done multiple different workshops. So if you're any corporate customer and if you want to run these workshops for your team to build them up to very speed quickly for Docker, Kubernetes, or anything related to DevOps, please feel free to contact us separately after this call. So these are some of the workshops we run for our customers. So with that, let's see what you're going to learn today. So we'll first begin with why learn Docker and Kubernetes. Then we'll first begin with Docker. So what are the Docker and what are the components of that Docker? What are the underlying building blocks in terms of storage, networking, the image? And then once we understand the Docker, then we are going to go to Kubernetes. And in terms of Kubernetes, why Kubernetes? What to use it? What are the pods? What are the architecture of Kubernetes? What highly available scape application? Or how do you become a certified Kubernetes administrator? We'll talk about that. Then we'll talk about the exam. And then at the end, I'm going to open up these question answers. We'll be answering, Mamta is answering questions behind the scene. My team is there to answer questions, and I'll be answering questions while Mamta is going to teach as well. As I said, the bonus or the free gift is only for fast action takers and for limited seats only. Now, as I said, we'll talk about that a little bit later. Now, just very quickly, for those who don't know me, I've been working into IT for almost 20 years. I started my career with Oracle. I'm awarded Oracle Ace, and it's similar to if you're coming from Microsoft background, MVPs. I'm among first few ones in UK to be awarded Oracle Ace. I've written books. I'm certified on a lot of Oracle or other cloud, Azure cloud certifications, and I go and speak at various events. And the reason for telling you is that whatever you're going to learn today is all coming from actual real experience. But the highlight of the today's show is Mamata, who is 15 years of experience, but one of the amazing speakers. You will, I haven't personally come across, apart from another one, which is Eva, I've not come across many who are not only have good technical knowledge, but also to share that knowledge, also to put that into story so that you stay engaged and you learn a lot. She is Microsoft certified trainer. She's Microsoft certified on various DevOps, Azure administrator, Google certified, Docker certified, Kubernetes certified. So you will see the depth of experience she has. So without taking a lot of your time or everyone's time, make sure I'm going to hand it over to Mamata, who's going to do the better job than I did to introduce herself. So she'll going to introduce very quickly to everyone, and then we'll take it from there. But make sure you ask, stay focused, ask a lot of questions, and as many questions as possible. So Mamta, I'm going to hand it over. So if you can share your screen, and I hope you can hear me. If you're speaking, you're on mute.
Yeah, hope my screen is visible to everyone.
Perfect. Yes, yes, it is indeed.
Yeah. Thanks a lot, and sorry, you guys had to wait for long. So, hey, hello everyone. Good evening and good morning as well. I'm really glad that you have taken out time from your busy schedule and invested on us. And I'm extremely sorry for the glitch which happened. We had not expected so many people. It's like no, too much of request bombard at the same point in time. So I had to quit and I couldn't join back. But I'll try my best to provide you a fair amount of idea about most of the one of the most buzzing technologies in the industry, which is Docker and Kubernetes. And I would like to simplify your technological journey and provide you with pointers to guide you to the best path. So let's start by analyzing the technological shift which has happened in the last few years from the time Docker has stepped in. So let's break out this complete session into few questions. Why to learn Docker and Kubernetes would be the first question. Then what to learn Docker and what would we learn in Docker and Kubernetes? What exactly is Docker and Kubernetes? Are they hot topic in the market? How much they are getting paid? What is the use of having a certification? I saw a lot of people asking questions regarding, should I get certified? What will I earn? How much if I get a certification, right? So we would be answering almost all the questions I would try to address. So let's start up by understanding what is the technological trend? How is the technological trend at this point in the market? So you talk about any big vendors or any MNCs or startup, everyone is working on containers, right? And this graph says about that. If you see from 2018 to 2020, a lot of people have shifted towards containerization. And this particular graph shows the percentage of your containerized app running in production. And we are hitting more than 50% of application already running in production in containerized environment. And we would learn about what exactly is the advantage provided by containerized environment and why people are shifting from virtual machine to the containerized environment. When we are talking about containers, we can't leave Kubernetes behind, because when we are talking about 5, 10, 15, 20 containers, we are well and good. But when we are talking about inter-host communication, when we are talking about multi-host running thousands of containers in a dev environment, test, staging, prod, any type of environment, Kubernetes is one of the best players in the market, which provides us the orchestration and management of those containers. And if you see, one of the biggest containerization management layer in the market at this point in time is Kubernetes, and it is 69% of the organization have already adapted that. So let's understand how is the trend in the market so that we understand why do we need to learn. End of the day, everyone has to earn their living. We have to earn our bread and butter, and we want to invest our time and career in technologies which are in high demand and would be in high demand in next 5 to 10 years, right? So this is the right place to invest, I would say. You can see around 39,749 big countries, big companies like this are already using Docker and containers. Top companies are hiring massively on these technologies. They are just looking for Kubernetes certified admins, Kubernetes certified developers and all, right? Atul showed a graph. We will go back to that graph again to see the technological trends and the job trends as well, right? And if you see the average salary, it's like $150 per annum for a certified person. So let's go and see how does the job market looks like. And from 2013, from the time Docker came into the market, you would see that there is a drastic shift, and a lot of companies are asking for such certified people, because whatever applications were running in virtual machines, everything is slowly shifting to containerized environment, and each single application is running in containers. uh, just to take an example or quote an example, we these days, when it is corona days, everyone is badly looking into Netflix. People are shopping in Amazon, Ola, Uber, any type of companies you talk about. Everyone's backbone is containers these days. Starting from, everyone has a Gmail account, everyone uses Google Map, everything is running in containers. And you would see that the beauty with which we are able to run on containers. Have you ever seen that you do a Google search, you hang, or Google search says page not found? That's not possible, right? That's the beauty of these things. And that is the reason slowly the complete market, the complete industry is shifting towards these trends, and people are moving towards containers. If you see the jobs availabilities on the market, this is from the US job market. If you see, everyone is looking for a Kubernetes certified admin or developer type of role, right? So there are a lot of openings, and when there are a lot of openings in US market and Indian market, why not to capture that, learn those technologies, and then grab those job opportunities, right? Because that would be the right time. So this
Okay,
was why
sorry,
we have to learn.
sorry.
Yeah.
Sorry, Mamta, before we go,
Yeah.
just very quick, two things which are coming again and again. So first of all, the job opportunities are not just for US and India. We've just shown you two, which is the big market, but they are, I see it everywhere, whether it's Europe, Singapore, Malaysia, Australia, Middle East, everywhere these are just showed because of the time. Second is, earlier, a lot of questions asked about is 150. It was actually 150,000. 150 is not possible.
Yeah. So
150,000 is average, which is on in my still in my view on a lower side. It's much higher than that. Over to you. Sorry to bother you guys. There is a lot of questions coming. I'm trying to answer as much as possible, but keep these questions coming and post those questions on the chat window. Over to you. Thanks. I'll not hopefully not disturb after this. Over to you, Mamta.
no, no, no issues. Thanks, Atul. Thanks for answering the question, because I'm not looking into the chat window because I've wasted already a lot of time of these people. I just want to focus on the technological part of it. So let's come back to this and let's understand why people are being so crazy in the market about Docker and containers or Kubernetes type of terms, right? And we will draw our analogy from virtual machine, because that is something we have been working on from last few years. So to coming with that analogy, let's first try and understand what's the difference between a physical server and a virtual machine. Then we would be able to draw the complete picture. What is the advantage of moving towards containers compared to the virtual machine? So let me quickly pull my sketchbook. Yeah, hope so everyone can see my screen. So when we were in the physical machine world and we had a single server, and I have to run an application, I get a server, I run an application, and I host that application and I can reach it from outside. And if I have to run another application, if I run it on the same server with a different port number as well and able to reach over here, I can't guarantee the isolation over here. I can't guarantee that the application one and application 2 will not trouble each other. They will not eat away the bandwidth or the resources which are needed for each other, right? The isolation was a problem. And in case I have to run one more application, what we used to do, we used to go buy one more set of server, run a set of application in that. So A2 is not happy running here. Even though there are two different types of application, I would go buy a physical server and run the second application over here. And now this is having a dedicated set of resources, so it is happy running over there. Then the era came of the virtual machine, in which VMware mentioned, or even before to that, IBM came with this technology, and we understood that on, on the same piece of hardware, I have a software called as hypervisor, and I can go beyond the hardware. I can abstract myself from the hardware, and I can run several machines inside this, and they would be in an isolated environment. I have machine 1 and I have machine 2, and we are running in an isolated environment. I have a dedicated set of resources for this, like 2 virtual CPUs, a 4 GB RAM, and same way for this as well, you can dedicate a set of resources. So people became pretty happy, and there was a drastic shift towards the virtual machine world. It was a complete change. Everyone left the servers, physical servers, they installed hypervisors into that, and they started using virtual machine. Exactly, we have reached the same era now, and we are moving out from virtual machines because we attained a set of advantages at that point in time, but we couldn't utilize the complete set of resources what was being provided by these particular hardware, and we were still struggling in few of the things. Like, I would take you back to the slides and then explain you. So we would learn about why virtual machines are having a set of drawbacks. And in case we have a virtual machine, we have an hypervisor. I'm running a guest operating system, and I am running binaries and the libraries, and then on top of it, there is an application. And if I have another set of virtual machine running, I have the guest operating system, I have the library binaries, and I have the set of services running on top of it, right? So what happens if I have to package? This packaging comes with the guest operating system. And what is the size of an operating system? To take an example of a Red Hat uh, 7.3 RTL7, it would be around 7 to 8 GBs. And when I'm saying I'm packaging 8 GBs, then the binaries, then the application. So what happens? The machines are getting the advantage that they have left the hardware level base. They are not virtualized environment, but they don't have the advantage that they are becoming bulky in nature. Even though they are having a dedicated OS, they are taking a lot of time to start, and they are becoming bulky in complete bring up. Why? Because this guest operating system takes a huge amount of time to boot up. When we are packaging, when we take a VMDK file, the image or a snapshot of a virtual machine, it's too bulky. So these machines are too heavy. And when I have to share an image, it is a too heavy image. So let's come back to containers and understand what are the advantages these containers are providing us, right? So I would have exactly same set of hardwares, and I would be having an operating system, and on top of it I would be running a containerized platform. Like, for example, Docker is one of the containerized platform, but Docker became so famous in the market that Docker has become a synonym for containers. So when we say Docker, it's actually, it has replaced the word containers in our world, right? So we are running any type of containerized environment. There are different containerized environment. There are Linux containers, there are Rocket containers, there are Mesos containers, and one of the famous one is the Docker containers. And if you see, this host operating system is shared across all the containers. And if I'm running the binaries and the applications, I am not having any OS attached to it. The bulky operating system has gone. So in the case of virtual machine, the operating system was sitting and eating the resources in terms of the memory, plus it was eating up the resources in terms of utilizing the resources of CPU cycles and all, because the system processes which are running inside the operating system also need resources. So when we are packaging containers, that becomes much lightweight. They are not bulky. Plus, if I want to package them separately, I can do that, and I can share the binaries and libraries when they are running. So in that way, the memory utilization on the server in which they are running is much more better compared to the virtual machine, where we needed a dedicated set of binaries and libraries to be used by a set of application. So here, applications get decoupled from the operating system as well. You would have heard a lot of people saying that I'm running a Linux container on a Windows machine. I'm running a Windows container on a Linux machine. They can't talk the language of each other's Why? Because this containerization tool which is there, the platform which is existing in between, does the translation. And that is the reason. Like, for example, if I take a Windows machine, I will install Docker for Windows, and on top of it, if I run in a Linux application in a containerized environment, the call which goes to the Windows operating system, which is the host operating system, gets translated in Windows terms. And if I'm running a Windows container on a Linux operating system, thereby the translation is done by the Docker software, which is running on top of the operating system. So this particular layer, the containerized platform which we are talking about, the containerization platform, is the magic which is there behind this. And it is allowing us to run many more things because of the bulkiness of the guest operating system which is removed. We can boot up our systems in milliseconds, and we are able to attain a lot of good things out of it. In case I want to scale my applications, compared to virtual machine, I can scale them much more quicker, because a virtual machine would take 2 to 3 minutes to boot up, and my Docker would take 3 to 10 milliseconds to boot up. So there is a huge amount of difference between the boot up time, the packaging, and all those things. And that is the reason people have moved towards Docker containers or any other containers compared to virtual machine, because hardware is very costly and they want to utilize the utmost capacity of the hardware resources which they have with them. So in the present set of hardware, if the utilization with 3 virtual machines is all bar filled, in case of containers, you would see just 1 bar is filled. And if the size of the memory, if you see, if it's using the huge lot of memory in GBs, your containers are using in MBs. And the boot up time is also huge in case of virtual machines, but in case of containers, it is pretty less. So this is the comparison. If we are comparing with something which we know, the analogy, deriving the analogy becomes much more easier. That's the reason we had this pictorial representation. And we understood there are a lot of advantages with virtual machine. I'm not saying that virtual machine is not good, we should not use it. It provided isolation, it provided a way of having the virtual applications run in an environment so that no one disturbs it. So Docker containers or any container technology have carried forwarded this particular thing, and they also have isolation. Some of the kernel features which are there uh, from Linux is being utilized, like the namespace provides isolation, and containers are happy running in isolated environments. They can't trouble each other, right? They are having a dedicated set of resources, and they would only go with that much of resources. And then we can limit the cap. We can put a cap on the resources with kernel feature called as control groups. And to manage the file system of the complete containers, we are using union file system, which works with full of pointers. And we know the magic of pointers, right? Addressing memory and all those things becomes pretty much easier, quicker, and the utilization of the resources in the memory becomes much more quicker and easier. Okay, so this was the underlying technology. Let's understand the
Yes,
concepts
sorry, Mamta.
behind that.
Before we go further, let me take a few questions, and I think you're doing brilliant job. There's a lot of technical content coming, but I'm also conscious of the time as well,
Sure,
everyone. So I'll keep it. I'll suggest if we can keep it high level. Couple of
sure.
questions I'm getting is Pratik is saying, do we need to learn cloud for this? Answer is no, Pratik. This is the Docker and Kubernetes are applicable for both cloud as well as on-premise. You can run it in on-premise as well. Now, another question was then why I need the Google container or Google Cloud. You don't need to run it on Google Cloud. You can run it in any cloud. Every cloud vendor has their own implementation of containers, like Google has Google container, Kubernetes and containers. Similarly, Oracle has, Microsoft has Azure, which is in have also on the AWS. So every company or all these cloud vendors have their own. Another question is coming is, can we use it only for, Vijay is saying, is it just for custom apps or can I use as well for apps GBA or for my WebLogic as well? So no, so you don't need to limit it just for custom. You can run it for WebLogic, databases, any standard application you can do as well. There are a lot of questions are coming. We'll cover that. Also, there was questions about the hands-on lab or what labs you should be performing. We are going to cover that. There's around 22 labs. It's just like we need to keep it high level, and there's more questions come. We'll go deep into that. We also have a follow-up sessions we might do in future. Yeah, over to you, Mamta.
Sure,
Let's keep it high level, please.
sure.
Yeah.
Yeah, sure, sure. So let's understand what exactly is Docker, right? We understood what is containerization, and now let's understand Docker. Docker is a containerization technology. It helps us in attaining good facilities like developing, shipping, quicker way of doing. It's one of the DevOps tools, and DevOps says a quicker time to market, a shorter time to market, right? Docker brings that. And because we are not dependent on the underlying operating system, it's providing a very less friction in shipping the codes and all. And that is the reason it is one of the best environments to develop, test, and even deploy. Let's see the architecture. So it is like a client server architecture over here. We would have a client from wherein you can run the Docker commands. We would have the host, which is actually running the Docker daemon, the Docker which we had seen in the previous slides, the containerization platform. That is the one which is called as the Docker host. It's running like a daemon, and we can create containers, and Docker daemon helps us perform everything, building the containers, building images, running the containers, and even managing the complete life cycle in a standalone machine. But if anything happens to the containers, restarting and all those facilities are not there. And when we are talking about Docker containers, we can't leave images. How without a operating system image, you can't boot a virtual machine. Same way, if you don't have a Docker container image, you can't boot a Docker container. So image is one of the basic building blocks of that as well. We would see the
Oh,
basic building
sorry.
blocks in little bit more in deeper.
Yeah, so I'll take the question again. There was a question, what is the use of image? So image, using image, you're going to spin off your containers. You're going to create containers, and you can add more and more on top of that. Yes, over to you, Mamta. Yes.
So when we are saying that we are spinning up a container, how we have a template or an operating system to spin up a virtual machine, our image of a container would be a thin layer of operating system plus the application. For example, if I have an Ubuntu thin layer, it would be 30 MB in size. It's not full bulky operating system. And on top of it, I have the Apache web server running, and it together would be consuming things in MBs. Okay, so that was the images. Let's see how the life cycle revolves around the containers. I can create a container and it gets created. Immediately it goes to the running state, and I can directly run a container without creating it with the Docker run command as well. And it goes to the running state. In case I want to stop a container, I can do that with a stop command. So Docker comes with very good command line tools using which we can run simple commands and attain that isolation, attain that limiting, and run application within microseconds. In case I want to delete a container, I can run a Docker rm command and the container gets deleted. In case I don't want to delete, I want to start a stopped container, I can do that and go back to the running state. If a container is running, imagine container is just like a process, right? An application process running inside that. You can pause them, you can unpause those as well and come back to running state. And in case you have created and you want to still go ahead and delete it, you can run the rm command and you can delete the containers. So this way you can manage the complete life cycle. I'm coming up with an application on top of an operating system, but the difference here, it's not a full-fledged operating system. It is only a thin layer of operating system which is needed for my application to boot. So if I take a Ubuntu image, I don't even have Vim, I don't even have Ping, I don't even have any application. I have to do a apt-get update and then get those applications or software packages inside that. Let's see, when virtual machines are running, obviously to reach them, we need IP addresses. Same way for the Docker also, we would be needing IP addresses to reach them, right? So there are different types of networking which are possible in Docker. But when the Docker container or Docker daemon is installed in a machine, it comes up with a default bridge, which is called as the bridge network, the Docker 0. It's named as Docker 0. So this is a machine. It could be a virtual machine in the cloud on which you are running Docker, or it could be a physical server. A lot of people are asking, where can I run it? You can run it anywhere, starting from a not bare metal, my bad. It needs an operating system below it. So you can run it on a physical server or a cloud as well. So you install a containerization platform like Docker. It automatically creates a bridge. And when you are launching containers, it would be created on that bridge. And this bridge has an external connectivity using the ETH0, the NIC interface of that server itself. And if I'm launching any application, it gets the IP address of the range of that particular bridge. And these IP addresses are dynamic IP addresses. They are private IP addresses. And if case they want to talk to each other on the same bridge, they can happily do that within the system, within the server. They can do that. And if they want to expose a port for the external connectivity, that also is possible. Port number 80 on the application can be bound to port number 5000 on the host. So whenever the packet comes on port number 5000 on the host, it gets directed to port 80 on that particular application. So here it is the translation NAT happening, network address translation, from the public IP address of the machine to the private IP address of the container over here. Coming to the storage part. So we saw a little bit of networking. I'm not going into deep, but just bringing up all the building blocks. We saw the networking part. We are getting an IP address. Let's understand how is the storage in it. Docker containers have few drawbacks. They don't have a static IP address. They don't have a persistent memory, and we would be covering that over here. So Docker containers base layer with which it comes up. Imagine that you're bringing up a virtual machine. You come with a image, and that image is a read-only image, right? You can't make changes to that. Same way, the read-only image with which the container comes up is the lower layer, and the top layer is the read-write layer on which you can write it. You are able to write on that layer, but that layer is pretty thin. How much you ask for, that much gets allocated. And when containers are starting, they would get both the layers, but the writable layer is ephemeral layer. It will not retain the things. So as soon as you make changes to your container, you take a snapshot and you prepare an image out of it, out of the running container. It's exactly the same mapping towards virtual machine. If I make changes to my virtual machine, I take a snapshot and have the latest image. Here also you will have to do that. But we can provide persistency to our application. How in virtual machines we are mounting disks, same way you can mount a path in the host on which the Docker is running inside the container, or you can have a volume, a network volume, which can be mounted inside the container. Coming to Docker.
Sorry, yeah, sorry. Let me take. As I said, I know a lot of guys are saying don't take questions or interrupting, but I think there are so many questions coming, and some questions are very useful. So, one question was about what is the role of Docker administrator going to be? So, setting up these persistent storage, setting up these networking, setting up, making sure that the Docker images can be taken up, which we're going to look at here. All these will be role done by the Docker administrator. That's where these are paid heavily. The Docker container or Docker administrator or Kubernetes administrator are paid heavily to do all these, because the skill set is not enough. It's fairly new, but hugely in demand, being implemented constantly. Over to you, Mamta. Thanks.
Thank you. Thanks, Atul. Thanks for answering those questions. So coming back to this, we discussed about images, we discussed about storage, we discussed about networking. So whenever a machine is running, we have the same things, right? If I have a virtual machine, I have a storage attached to it, I have an image with which it starts, I have a networking associated with it. So container is nothing much different than a virtual machine, but it is smaller in size, it is not bulkier, it is not associated to the underlying operating system, and that's the biggest advantage. What advantage do I get if I'm not tied up to the operating system? I don't have the dependencies in the environment variable tied up. If I capture the image of a container, I have all the dependencies involved or captured in it in the snapshot itself. If I talk about virtual machine, when I was with Alcatel Lucent long time back working on telecom, I used to face hell lot of issues when I used to provide the images to the testers, and they used to say, Mamta, it's not working as expected in a QA environment or the regression environment, right? Because the dependencies are not captured. So we can automate the image creation, because that's one of the biggest thing. Using Dockerfile, we write a script and that helps us creating the images and deploy the container, and we can version control these Docker files so that we can have different versions of the images, and we can keep a log of what was the changes done in it. So Dockerfile is the method with which you can automate the image creation process. So let's understand, in case we want to learn Docker, what exactly we have to learn. We have to learn how to install Docker. We have to learn how to work with containers, what are the commands are, how to create an image, how to delete an image, how to tag an image. Once containers are there, how the networking part is supposed to be configured, how to delete an image, how to tag an image. Once containers are there, how the networking part to the neighboring container, what would be the IP address? Do I launch my container on the same bridge? Do I need a custom bridge, or do I need a different type of networking altogether? There is host networking, non-networking, there are different types of networking. And once the networking is in place, we would go to the next building block of the storage, how to mount the persistent storage inside that, the storage and the volume, both the host path mounting and the volume. And once these are running, we should be aware how the logging is in place, how the storage drivers are, who is resolving our DNS and all that stuff, right? So those things has to be learned in depth. And then we would be learning how to automate the stuffs with Dockerfile, Docker Compose, and bringing up the complete application stack all together. So if I have a web server and a database, I'll create two containers and make them run together. So here we covered the Docker part, and we understood that containers are providing a lot of advantage, but I mentioned there are a lot of disadvantages as well, right? IP address is not fixed. The storage is not persistent. You're able to mount the storage, no doubt in it. But till the time we are talking about Docker, I never mentioned that inter containers or inter-host communication was possible. Like this, talking across host is not possible with plain Docker. And why is that? Because it doesn't have the capability of doing bridge-to-bridge networking. To uh, do a bridge-to-bridge networking, we need something like a gateway bridge. And that is when the tools like Kubernetes and all come into picture. Kubernetes helps us manage the complete life cycle. If I have 5 containers, 10 containers, it is much more easier to manage on a single host. But on a production, I will never leave with a single machine, right? I would be having lot of machines altogether. And if containers are running in all the machines, there are 1,000 containers, someone has to manage that, and this is the management layer. And if you see, containers are existing in the market from the time Linux is there. Google has been one of the big time users of it, and they have been using from the first product they came in the market. And when they saw Docker has come up with such an easy solution in the market, they donated the Kubernetes, which was the Borg project inside Google. They donated it to the Cloud Native Computing Foundation. So Kubernetes has originated from Google, and they don't maintain that now. But yes, that is a technology which is behind all the Google services which is being provided. So when we can't live with a single server in the deployment, when we want inter-host communication for containers, when we are deploying and updating software every now and then, and when we are scaling as well, or we want a better management capabilities, or we want auto healing thing. If something goes down automatically, it should get recreated. Then the answer is Kubernetes. And in case we have logging and monitoring, that time also Kubernetes has better solutions to provide. So let's understand what exactly it is providing. It is providing all the building blocks. It helps us deploy, it helps us manage, it helps us scale the containers as well. And if you are running a container, it helps us edit the container, it helps us updating on the run the containers, it helps us in scheduling as well. I am running an application and it can be scheduled in any of the nodes in my particular region, right? If I want to be a zone specific deployment, I can do that. If I want to be a rack specific deployment, a host specific deployment, there are advanced scheduling techniques with which I can attain that. And monitoring and logging is one of the other best things which we have. And then authentication and authorization is very important. So it has role-based access method for the authorization. And because this technology is one of the hottest technologies, and everyone is shifting from the virtual machines to the container world, all the bigger cloud providers have obviously have to provide solutions. And Amazon was one of the first beginners to provide that. They came with Amazon EKS, then Azure came with Azure Kubernetes service. We have Google Compute Kubernetes engine. We have Oracle's container Kubernetes engine. And then we have DigitalOcean's Kubernetes service as well. So these are one of the cloud providers. Everyone is providing that. A lot of people were asking which one is the best Kubernetes cluster, right? Everyone provides the same. You deploy a Kubernetes cluster on on-prem or on cloud. It all doesn't make much difference. If it is on cloud, it is managed service, then the management part goes to the cloud provider. Otherwise, it's all same. If I have to work with it, same command, same setup, same set of things, everything works as it is on every cloud provider or on on-prem. In on-prem, or you are doing, or if you are setting up not as a managed service, then the management headache is with you. That's the only difference. So let's see the
Sorry,
architecture.
Mamta.
Yeah,
Yeah, okay, go
yeah.
ahead. Go ahead. But there are a lot of questions are coming, and I wanted to take a lot of questions, and they are very, very good questions. Some guys are asking about a role of Kubernetes or what task you will be performing. But I'll take these questions. You carry on. I'm looking at the, yeah, carry on, please. Yeah, thanks. Over to you.
Fine. So here we would be discussing about the architecture on a very higher level. So when we talk about a cluster, I'm saying there are a lot of machines in the uh, setup, and all of them are running containers. Obviously, someone has to monitor them, right? So think there are a lot of machines over here which are running Docker, and they can run containers in them. So someone like a master node has to sit and dictate on what to do and what not to do, right? And in that master node also, because these guys are preaching containers, they run their services also as containers. Kubernetes processes also run as containers. Let's see what are the master Kubernetes processes: API server, control manager, scheduler, and etcd. API server receives the request. Controller manager is for controlling the auto scaling, auto healing, all that roles is done by them. And then the scheduler is there. Scheduler does the scheduling part of it, because we are no more on a single host. I create a container and runs on that host. That question is not there. Now the question is where this container would get placed in the cluster. So scheduler is the one which takes the decision. And then we have the etcd, which is the configuration map. We have to back up this guy pretty well so that we have the complete configuration saved with us. In case something happens to our cluster, you can restore back from your etcd. So if you have an admin guy and you are setting up this complete cluster, master comes up with these roles and processes, and the worker nodes comes with the agent. Kubelet is the agent with the C advisor. It comes up together. C advisor helps us in monitoring the resources utilized by the containers which are running on that particular node. And then kubeproxy is the one which is providing us the ability to reach those containers. So here master is the control plane part, and we are talking about the data plane part. Then kubeproxy will come into picture. Now to stitch up the complete networking, there is something called as container network interface plugin that will come into play, so that all the nodes in the cluster gets connected, including the master. And if a dev guy or an admin guy talks to the Kubernetes cluster, the request goes to the API server. It picks the latest configuration from etcd. If I'm creating a pod, it will go to the scheduler and request where should I get placed. The response comes back to the API server, and the desired, the picked node would get contacted by via the API server. So the kubelet, the agent which is running, that would receive the request and it would contact the Docker, because Kubernetes is a software which can manage and orchestrate containers. It doesn't have the ability to spin containers. So it will go to the containerization tool like Docker and it will spin up containers. For now, just ignore the word pod. We will be going to that in few moments. So pod is the container type of thing which gets spinned up and the response goes back and everything gets updated. Same way, if I am having the controller in place so that in case I'm running multiple replicas, it can manage those replicas as well. And if someone tries to reach my application from the outside world, it is coming to the kube proxy and that leads me to the pods inside that or the containers where the applications are running. Now let's
Sorry, before we
understand.
go, sorry,
Yeah,
before we go, I think I need to take it here. If you go back to the previous slide, I know it's
yeah,
too much information into, and I think maybe we might thinking, oh, is it, have we done too much into one single program, or we should have done it broken down to simple two things? So give me a feedback. Is it all making sense, guys? Just tell me, is it all flowing? Is it understanding, or is it too much confusion? Put it. I know there's a lot of moving parts here and a lot of content, but is it all making sense? So in a nutshell, to recap for a little bit slow down, you have a container which is something similar to your, in a layman's term, I'm telling you, you have a container which is something similar to virtual machines, but a better and quicker way of doing virtual machine takes a lot of space, memory, time to boot up, and whereas containers are very quick to spin off, build, run application. You containers are not just for a custom application, they can run any even heavy duty applications. That's a question I'm seeing again and again. So you can run your WebLogic, you can run your database, you can run your Apache, you can run your web app, anything that you can think of, run it. Now it's not just for cloud, it's for basically on premise as well. Another thing is, now you run hundreds and hundreds of containers or applications running on containers, they all need to take to each other. So that is uh, that containers needs to talk to each other. And so in order for these containers to manage them, also to orchestrate, start, stop, manage, talk to each other, that's where Kubernetes will come into picture. So think of as a Kubernetes as a master which is managing all these small containers. I hope that makes sense. So we're going to come what is pods. She's going to explain it in a minute. Now one more thing was asking question, someone was asking, in the training program we are going to cover which particular Kubernetes engine. So is it so Mamta, can you cover that
yeah.
quickly in
So
terms in the training
in
that we are going to
yeah.
cover in the end? Which one we will cover? Yeah.
Yeah, so in case we are learning the managed services, we don't learn the master block. That's the reason we would be deploying the Kubernetes cluster from scratch. There's a tool called as KubeADM, which is normally used for that. We would be deploying the Kubernetes cluster using that, and then we pick up one of the cloud flavors and see how does the managed services also work. So we have both the flavors of it, non-managed and managed. And
Yes.
I see few of the questions. I would like to respond to few so that people don't fall behind and they are unable to relate. The full form of RBAC is role-based access management. Kube proxy is the component which helps us with the data plane part. In case I'm running my web server and I want to open my web server like say amazon.com or google.com, my packet would be landing to kube proxy, and rest all the paths over here, whichever it's mentioned, that's a control plane part to manage the complete life cycle of controller containers. Kubelet, C-Advisor come together. They are as the agent running to listen to the master and do the tasks on that particular host, because when the master is saying run a container, someone has to obey the rule in the worker node, right? And that is the kubelet component over here. And yes,
Perfect.
I didn't.
Perfect. I think yeah.
Yeah.
Sorry.
So I'm going to the
So
next
sorry. Go ahead.
slide. Yeah.
Yeah, so before
I'm
go
going.
one more time, like
Yeah.
sorry, Mamta, that's fine. It's okay. We can extend a little bit more, and if people are getting value on that, if you go into
Yeah.
previous slide one more time. So
Yeah.
another question is like, how are so Kubernetes? So question was again, is it like Kubernetes is a manager which is managing all these different containers running on different machines. Uh,
Yes.
the
Yes.
another question was,
Answering.
what is then Docker Swarm? So Docker Swarm is something similar to sorry, Docker Swarm is from a company called Docker, which is similar to Kubernetes, but Kubernetes is much more common and implemented commonly. Hence, we recommend
So I
everyone to
would
go
like
for
to add over
Kubernetes.
here, Docker came with Docker technology in 2013. Kubernetes donated Kubernetes, the Google donated Kubernetes in 2014, and people drastically started using it, right? They became crazy and they started using it. Docker Swarm came in 2014, but it didn't gear up that much. It didn't catch up the market because Kubernetes was being utilized by Google for 10 years and it had the full-fledged features. Docker Swarm doesn't have that many features compared to Kubernetes. That's the reason in 2017 in Docker conference, Kubernetes got combined with Docker Swarm. And if you are using Docker Swarm, you can still go ahead and maintain your manager containers using Kubernetes. So Kubernetes is much more advanced and highly skillful tool to manage and orchestrate your containers, which are running across different hosts. So yes, it's a master which is managing containers across different hosts. Yeah, sorry to cut you on that, Atul.
No, perfect. I think well done. Thank you very much. Let's continue from there. It's perfect. The whole point is about people should understand it. There are a lot of questions coming. Now, what's happening is people don't see the questions, but I'm getting hundreds and hundreds of questions. And it's always good to take a pause and understand because some guys are getting, some are not. And we want to ensure
Yeah,
that
because
everyone is going
if
ahead
I
together.
leave
Yeah.
leave the
Over to you.
question unanswered, people don't follow from that point. It could be a possibility, right? We don't want to do that, neither in this session, neither in our training. We love to answer the questions, whatever it would be. If in case we don't know the answer, we come back with the answers to you people. So let's switch back to the session now. Till now, I was talking about container, and suddenly Mamta brings a new word called as pod, and people are astonished. What is this pod? You said Kubernetes manages containers, and from where this pod new terminology is coming into picture, right? So you have a worker node on which you plan to run containers. So you have Docker and you have the agent running over there. And in case you want to package a container so that Kubernetes understands it, and that is called pod. Pod is like a wrapper which is wrapping our container. Our application still runs in container, but it is wrapped by a covering called as pod so that Kubernetes can manage it. Because the management at the end of the day has to be done by Kubernetes. That's the reason we do that. So my pod can be a single container, or my pod can have multiple containers, a group of containers as well. So pod is the smallest unit. I can bring up a pod with a single container, or I can bring up my pod with a group of containers as well. And when we are bringing up them, how containers used to get IP addresses, the IP addresses are tied up to the pod now. And when we are tying up these IP addresses to the pod, containers would be sharing the port namespace or the port network port space inside the pod's IP address. So just imagine giving a very silly example. Pod will get an IP address of 1.2.3.4. Then container can open a port 80 and listen on 1.2.3.4:80. If I have two containers, one can listen on 80 and one can listen on 81. So when we keep multiple containers inside a pod, when there is real a necessity. Someone had posted a question. I hear the terminology of microservices a lot. Yes, when we are talking about microservices, containers comes handy with it, because when we are saying it's a microservice, it's a very small application, and we can bring very small application in a virtual machine. It will ruin the resource utilization, but we can bring a very small application in a container, and that gives us the maximum utilization of the resources. So when we are saying microservices, microservices are running as containers. Just to correlate what exactly is a microservice, suppose everyone does shopping on amazon.com, right? You have a authentication authorization service, you have a product catalog, you have a say billing, you have customer liking things, the customer reviews. So each is a different service. Have you ever seen Amazon showing, for not for very rare case, the doggy comes into the picture, right? But in case it would have been an application which has clubbed everything together, if one thing goes wrong, the everything stops working. So here every application authentication is an independent application which is running in one container, authorization is running in one container, billing is running in one container, you are running product catalog in one container. Like that, you have distributed. It's a distributed microservice architecture, and they talk together and make the complete application. In case something is not working, you will not realize. So life has become easy, applications are always up, but life is much more difficult as well, because when they were sitting together, they were talking well, and there was no latency and all. Now I'm spreading them across hosts, so network latency and a lot of things comes into picture, right? So microservices, container, Docker all come together when we are talking about all these technologies, and Kubernetes is the one which helps us manage them. So coming back to this, I said pod gets a dynamic IP address, and it's not a static IP address. So if the pod restarts, the IP address changes. So just imagine I have a database running inside a container and my IP addresses changes. My web app can't reach my database, and then that's a big trouble, right? So for that case, they bring up a static component called as service, and when we have a pod running a container, it gets an IP address, but it gets a static IP address with a service. Now you will say, Mamta, when container goes for reboot, IP address can be regenerated or released and recreated, right? Then why service can't lose its IP address? Because service is not a process which is running. Service is just like an entry in the system. We have allocated an IP address, and unless and until you go and delete the service, the IP address will not be lost. So we would reach the database using database service IP, and then we would reach to the containers. So service is providing us the static look over there. So here service provides to solve that connectivity issue which we have in containers of the dynamic IP address. It provides us a static IP address. It helps us expose our application to the outside world, or to within the, sorry, or within the cluster as well. So that's the beauty of services. Now just imagine, I know I'm going pretty fast, just to get a brief understanding. You have a lot of applications running, and one application you can never uh, get it down, right? I have a server running, I don't want that to go down. So how do I run in a virtual machine? I run them as highly available with a scale set and all, highly scalable, right? Same way, when I'm running containers, I would run multiple replicas of containers, how I was running multiple replicas of my virtual machine. Difference: virtual machines were scaling in minutes, replicas of containers will scale in milliseconds. So let's see, how does the replica scaling and all happen? We saw schedulers role, we understood etcd's role, we understood kubelets role, we understood docker's role. There was a control manager which was hanging there, and we didn't focus that much on that, and now that's time to focus on that. Deployment is a type of controller which gets created, which helps us manage the replicas. If I say run 3 replicas, it will run 3 replicas. If I say scale to 10, it will scale to 10. If I say scale down to 3, it will scale down to 3. So deployment gets created, it in turn goes and creates those replica pods. And in case, and again, I am wrapping it up with a service so that it has a static IP address, other containers and all can reach it. And in case someone wants to access from outside, how I showed that on the ETH0 of the host, the container can expose a port. Same way here on the node ports, you are exposing the container, and there is a mesh network inside. Even though your container is running in worker node 1, if you reach on the port number on the worker node 2, which you have exposed, your packet gets routed over there. So here the routing is much more complex, but it is much more quicker as well. You will not feel the delay, and packet would get routed to the correct destination wherever your container runs. And one point in time, if you want to really scale up, you can scale as well, and you can do the load balancing across. How we have a load balancer in front of a virtual machine, same way you can have a load balancer across containers as well. So here load balancing can happen if you are deleting a pod, that pod deletion manually you're deleting, or you are accidentally it got deleted or restarted, it will come back. Deployment will make sure that it brings back that, because deployment's work is to auto heal. We were talking about Kubernetes doing auto healing, auto scaling, right? We saw it scale the second replica. It heals the replica here. It brings back the pod. And if you see, the pod came with a new IP address .5 at this point in time. And when it came with a new IP address, still then the reachability to that particular has not changed, because every time my service IP address was constant. And I sent packet according to the service IP address. And in the backend, service work is to keep monitoring whether the pod went up or went down. It maintains the IP address in the endpoint list. Okay, so here, this is the way we can set up a complete highly scalable application, and we can do a lot of load balancing and all in comes into picture. So let's understand, in case we want to learn Kubernetes,
Yeah.
what all things
Sorry, we'll go back to
learning
one
is
more time.
beneficial. Yeah.
Sorry, before we go back to again, I just want to reiterate, there are a lot of questions coming of the previous slide. Yeah, so this is just to show you that this is possible. You can run highly available application which are scalable, which has persistent, which has a data session persistent. All those things can be run. Now, if you're confused how these are, it's almost very difficult to cover that much into 1 hour, but you understand the depth and what it can do and what are the capabilities. Of course, that's where it's a very comprehensive. This whole thing will take a day in itself to cover everything in itself. But hope you
That's the
understand the
reason we're
concept. Like,
having a 12-week session, Atul. It's not a single day's
exact
task. It can't be covered
exactly.
in an hour's session. That's the reason we plan to do a 12-week session, because it's a huge. Someone had mentioned that, Mamta, Docker and Kubernetes is an ocean. Yes, very correct. It's like an ocean, but it's not impossible to learn, I would say. We can learn them in a small building blocks. We can cover small topics, and then do a tick and understand, okay, networking done, storage done, and we can cover a lot of stuffs. So I'll also Atul, let me take a few of the questions which
Yeah.
we have
No, no,
seen over here.
we'll cover all the questions later. Yeah, we'll cover the questions later. If you go further down,
Okay.
we'll cover those.
Okay.
One quick question point was about should we do Docker or container first? My question is, why not do both? In the program, you to get both Docker and container. They go hand in hand. Now it's more pretty much extensive hands-on. It's pretty much entire Docker Kubernetes we were discussing earlier in labs. These are all in certification as well. These are hands-on. So if you enjoy hands-on, if you do things, that's when you're going to learn on. And there's a benefit of learning all this is because you're not learning just for now, if of course it's paying very good, but this is where industry is moving. What virtual VMs were probably 10 years ago is exactly where we are now, which are containers and Kubernetes for us. And all these applications that you know are going to run or running inside container already, or if not, they are started now packaging into. That's why you see any cloud company, they are now putting every application inside containers and Kubernetes. So be it Oracle Kubernetes engine, Microsoft Azure Kubernetes services, or AWS Kubernetes, or any cloud you see, or on premise, everyone is running towards container applications. With that, I'm going to hand it over back to you, Seema, on that cover. See what all hands-on people should be doing and learning. Over to you.
Yeah, thanks, Atul. So here I agree, there are a lot of things covered. We are just giving you guys the pointers. If you have to learn about Docker, why we should learn about Docker, why we should learn about Kubernetes. As Atul mentioned, why not learn together? Because no one would be running only containers, right? This is a world where a lot of applications, the application is broken into multiple parts. As I gave an example of Amazon, it's broken into multiple parts, and if you want to make them work together, you got to know Kubernetes. It's not the single application you're working with. So let's see what sort of hands-on would be needed. You will have to learn how to bring up the complete cluster from scratch. You will have to understand how the cluster comes up in cloud. That would become much more easier for working once you know things from scratch, right? How to run a highly available application, the example which I saw showed you the deployment type. In case we are rolling out the new features, version 1 to version 2, we are going, how do we do that? How we roll back, blue green deployment, a lot of things are there in that, right? How do I scale? How do I scale down? In case I'm exposing, how do I expose only within the cluster? How do I expose outside the cluster? How do I expose with the load balancer? And there are different types of networking with respect to ingress controller. They are layer 7 type of load balancer. Then from networking, we will switch to the volume part of it, how to get persistency. In case when we got persistency, we would understand how to deploy a stateful application, a database, a distributed type of application, how they work. In case I want to run daemon type of application, how should I create that in Kubernetes? So there would be a hell lot of YAML files which we have to learn how to write it, what all parameters. And once we know what sort of things we got to create, then we would go and tweak and understand how to get it more scheduled type of environment, right? How to do the advanced scheduling, how to limit the resources in containers, how to limit resources on the cluster level. If a node is there, how to maintain it, how to troubleshoot in case there is a failure on an application layer, node layer failure is there, or something has gone wrong on the kubelet, something has gone wrong on the Docker. Everything would be packaged and covered over here. Then once our cluster is up and running, we are able to troubleshoot. When we are troubleshooting, we got to look into logging. We got to monitor the stuff. So logging and monitoring is very important. And the most important part is security, because when we are running a cluster, our complete cluster has to be secure. So security is one of the important aspects which is covered. So these are few set of examples I'm saying. These are the minimum things you got to learn, and we would be covering these things as part of the exercises. As Atul mentioned, CKA and CKAD exams are all 3 hours hardcore hands-on exam. Unless and until you practice, you don't learn. It's not like a multiple choice question like any other cloud provider exam, right? So these are tough ones like the Red Hat certifications, and you've got to do a lot of practice, which we would make you guys do, give a lot of examples so that you prepare yourself better. And why not get certified when you learn
So,
things, right? When you're looking,
sorry, if
sorry.
sorry, Mantha Agwarian. Sorry, I'm sorry. Go ahead.
Yeah.
Continue.
Yeah. So I was saying that what do you think in case you have a CV of the left hand side? I interview a lot of DevOps guys, right? I would go for a CV which is there at the left or the right. I know that other guy on the left knows Docker and Kubernetes, but people prefer people with certification because this is a 3 hour hardcore certification of hands on. People understand that with multiple choice you would not have passed. There's no dump that will make you pass over here, right? You will have to learn these technologies by practicing, and when you get that logo in your resume, that carries a lot of weightage. So let's see what is the certification roadmap looks like.
Sorry
You have,
again,
yeah.
Mamta, I'm going to interrupt before we go. Can you go back to the slide again where with the hands-on one or couple of questions were coming on the hands-on the previous one? Yeah, previous one. So there was a question: how much system admin knowledge is required to become Kubernetes admin? Will it be very challenging for DBAs or application admin? Bijal, absolutely no. I come from a administration background where we manage applications. If I can do it, there are a lot of other students like
I,
you
I
who are coming from.
I would
Yeah,
say
sorry.
Atul, I would say Atul, in this, a lot of people have asked this question, Mamta, if I'm coming to your training, what do I come with? I would say come with a free mind to learn stuffs. If you know a little bit of Linux, I can teach you Docker and Kubernetes. If you just understand what is a CPU, what is a memory, what is a disk, what does a machine look like, we can teach you what exactly is a Docker and containers, what exactly is a Kubernetes, how does it work. It's not that difficult technology to learn, but yes, a practice would be needed, which we will make sure that you guys do. I would say that.
Just to add to that, so let's take a few more questions. Matthew is saying, do we need any DevOps knowledge to learn container and Kubernetes?
No, no,
Wonderful. Okay, is Oracle supported on containers? Absolutely no. Yes,
yes,
it is. Both
yes.
WebLogic applications are supported. As Yeah. So what is okay? We'll cover that. There are a lot of questions now started coming. Is it right for me? Is it for? We'll cover all these questions in a minute.
So we
Yeah.
have those slides going forward. Don't worry. Whether who
Oh,
should
great.
learn, and yeah. So we would cover that. So just let's see what sort of certifications are there. Admin certification is there. Developer certification is there. Admin certification focuses towards administration. Developer certification focuses towards the developer's roles and responsibilities, right? So who should do the certification like you guys are asking? For CKA, I would say, because in every cloud, these guys are uh, working with Kubernetes. So whoever is a DevOps engineer, obviously a DevOps architect, because you've got to architect the design in a containerized environment, so you can't run away from that. Any cloud engineer guy, any cloud you talk, someone was asking in Alibaba, do we have the solution? Yes, every cloud has containerization and Kubernetes solution. And any cloud architect, because the era has gone when applications were running in containers, when applications were running in virtual machines. And the era has gone for an application with joint architecture, that multi-tier architecture has gone. It is all distributed architecture. And when you talk about distributed microservice type of architecture, you've got to learn containers, otherwise you can't survive in the market. Let's see, if I have to do this exam, what I should learn. Application lifecycle management is something which I have to learn. I will have to learn installation, configuration, and how do I validate that configuration. Core concept, what is a master node, what is a worker node, what all components are there, how do they work with each other, how is the networking, how is the scheduling done, the security aspects, how do I maintain the complete cluster, logging, monitoring, storage, and the important part is troubleshooting. If you see, the maximum weightage is given to core concept, networking, cluster maintenance, and then the installation part. And after that, those are small pieces of scheduling, logging, and monitoring. So I would say it's a complete package. You got to learn a lot of things, but yes, it's not impossible to learn. It's not rocket science. It's something which is you would be going and using day in and day out in future. So it's best time to invest, because when a lot of people are certified, we fall back in the race. So let's see, if I'm preparing for the exam, what are things I need to know. I should know that the exam is for 3 hours. If I score more than 75%, 74%, my bad, I attain a certification and I get a free retake. And if I don't pass the exam in the first attempt, I would get the second attempt for free. And I get 24 questions, and I get 2-3 different types of clusters. And in those clusters, you have to either spin up a scalable application, you have to spin up a database set of application, you have to have auto healing configured, you have to have a storage configured. So they'll give small tasks which you got to do in these 24 questions, and at the back end they would verify it with the script, and you get your certification in a day or two max. So with this, my part is ended. In case I have to answer any questions, Atul, do let me know. uh,
Yeah, if you can hang around this hundreds and hundreds of questions, guys. So if you
I
can,
should
if you don't mind, if you
I
can
make
answer
you
that behind the
presenter,
scene.
Should I
Yeah, you
make you
make me
presenter?
presenter. I'm going to make myself presenter now.
Okay.
And guys, tell me just first, genuinely, I know it's a little bit too much, and she's tried to cover a lot of ground, and I think to a level which I asked her to do that, and I know because I said give as much as you can, and she's a complete giver, and you might have seen oh, okay, there are a lot of questions coming about course duration. Which one do we need to do, DCA first? No, a good one. Okay, great, guys, thank you very
So
much.
I'll
It
answer
was
that
extremely
question, Atul, the DCA part one. Maybe just excuse me for answering that.
sure.
So a lot of people say that should I do a Docker certificate and then go for a CK? I would say it's not preferred. I myself, I have done a Docker certified associate certification. Still then I say no, because for Docker certification, you got to learn Docker Swarm, which is one of the heaviest percentage in the examination, and people don't use that much in market. You would not find Docker Swarm openings that much, how much Kubernetes openings are there in market. So why not invest time learning the basic building blocks with Docker containers and then move to Kubernetes? Because without Docker, you will not understand Kubernetes. And why to invest on a competitive technology which is not hot in the market and no one is looking for that much of job opportunities, or job vacancies are not there. So invest your time learning containers which are Dockers, which are hot, and then go to Kubernetes so that you get the certification of Kubernetes. And once you have certified in Kubernetes, people automatically understand that, yeah, you know containers, otherwise you can't manage them, right? So just focus for either a CKA or CKAD. And CKA is much more better one, Once you know CKA, automatically you go back to LinkedIn, and my bet you would see everyone has both the certification. You target for one, and little bit delta studying, you get certified for the other one as well. Sorry for that.
No,
I
I think
become
this is
crazy
exactly
when
I
people
wanted to
ask
hear.
why should I not do DCA.
No, no,
I
no,
did
no, no,
that,
no, no,
but
no.
there was no added advantage in my profile with that.
And absolute spot on, because I remember now a couple of weeks we were discussing, or weeks and weeks we spent a lot of time into giving the best option, and we were discussing going to and fro, should we do about Docker, Swarm and other things. And that's where you said, and this is where we optimize this program in a way saying that whatever is required we'll cover that, and whatever is not required as per the industry, don't do that. We don't want you to do more than what you need to, but at the same time we want you to be expert in what you do. Whatever is required, everything, put it forward and do. That's why it's comprehensive. 33 module, 33 hands-on lab, 11 from Docker and 22 from Kubernetes, the best of both the worlds. That's why it took so long, because a lot of guys were asking in our various programs for that. But I'm glad that you asked, and there are a lot of questions coming about fees, duration, class. How do you do that? I'm going to cover all this as well. As probably Mamta already said, if you do the administration, the development will be easy. Or even for if you're going for development, first understand the administration for architects, so that you understand the whole architecture, how these are done, and then development becomes very, very easy. So we are going to cover both Docker and the Kubernetes in the program. But let's first quickly tell about the learning path. We've already covered. Mamta is brilliant in that, and thank you, big thank you for Mamta. But let me very quickly tell about, you start with containers. We cover containers basics, container networking, images. A lot of questions were coming today about Docker images. How do we maintain, manage them? How do we do networking, storage? All those will be covered in the Docker container, or should be covered to begin with in Docker networking. Then Docker storage, images. How do you check in, check out? Docker compose, all those things will be then a Docker. Once you understand the Docker, then you go to the Kubernetes in terms of creating the Kubernetes architecture, underlying components, master work node, worker node, all those. Then you also look at networking, but this time from Kubernetes, storage and networking both from Kubernetes point of view. Then how do you administer these? What are pods? How do you deploy? How do you deploy the applications, static pods, schedulers? How do you initialize these containers, etc.? And then how do you limit these resources if you have to? So all the administration part, scheduling part. And then comes security, very important thing. How do you secure them, troubleshoot them, do all these activities, and actually do hands-on? And once you do all this, then you write an exam, which is Kubernetes certified administrator, or certified Kubernetes administrator, and you then being awarded with certified Kubernetes administrator. Very, very highly paid. If you look across anything, any job opportunities now, start looking and type Kubernetes, you will see hundreds and hundreds of job opportunities with Kubernetes. So these hands-on lab, we Mamta already covered for related to Docker. 11 will cover everything on Docker container. We don't want you to do Docker Swarm because it's complicated, it's not used actively. So Docker container is more than enough. That's where you do 11 guides, and don't do Docker certification, rather do Kubernetes certification. And Kubernetes, you do 22 labs, and that will cover you end to end, covering everything. And a lot of questions came, which one we are going to cover? We'll focus on Azure, which is more hot. You can do on premise, you have your own Linux server, or operating system. You can build on that as well. We'll show you that as well. But we are going to use Azure. We'll give you how to create an account in Azure. All those things we'll cover for you. So all, as Mamta said, you need to come with a mindset to learn and be attentive, and a laptop with a good internet connection. That's it. You don't need anything. We'll do most of these things on cloud. If you want to build your on premise, you can always do that. So these are all the Kubernetes labs. We are going to do not 1, 2, but 22. It's complete hands-on with all the theory part as well. What we looked at today is just a glimpse of that program. So not once you have done, once you have learned, then make sure you prepare a CV, and well done CV, not just by writing simple things, but also elaborating what all things you have done in this Docker and Kubernetes, and what you can do for customer. What are the common implementations you come across? Put that in the CV, and then apply for the job. I can guarantee you, you'll definitely get very high paid job if you have little bit smartness, which will which pretty much everyone, those of you who are here, have shown by asking the kind of questions. So you'll see whether you're in, we've just picked up a couple of job opportunities, but it's full of 100 plus jobs: US, India, UK, Middle East, Singapore, Malaysia, all the places. Now, as Mamta said, it's all possible, it's all achievable. It's other guys who have uh, done or got the success and results, provided you do the work. So this is just one example of one of the program members from a different program. She's Rajalakshmi, took a break of 2 years. She was pregnant. She was expecting a baby, had a baby, and had a 2 years a break, and then moved into the teaching line, or moved back into the into the job in US itself. Or you might be already implementing for Kubernetes, but you need some confidence, you need someone to tell you what you're doing is right, and this is where the guidance, help, and community comes handy. Now, the question comes is, how do I learn all this quickly and effectively? There's so much to learn, but how do I learn quickly so that I stay ahead in the curve? I learn these things quickly. And this is where the comprehensive program, it's a 16 module, 60 plus lessons, 33 hands-on labs, exam preparation, and the most important part is important here is on-job support. We provide 1 year on-job support. When you do these kind of jobs, you will still need a lot of questions. You will have a lot of questions come into mind, or you will be implementing for customer. Now, what happens is with a lot of other institutes, they give you training, and after that, you're on your own. And this is where we realize that you need a lot of hand holding initially, and once you are on, then you can do things on your own. That's why we provide 1 year on job support. So we'll teach everything, we'll do all the hands on, but we also prepare you for exam, and as well as then post exam on job. So why we are different? As I said, 1 year on job support, pretty much no company can, I can guarantee you, we can provide. That's why I have a huge support team to cover that. Most of these questions are will be coming repeat questions, same question I see here as well, same questions. So we already have huge list of those answers for you. But on top of that, things keep changing, new things comes, and this is where if you stay attentive, or if you're in the program, we can help and answer those questions. 1 year on job support, you have unlimited retake, which means what that means is that you come to the program, you attend live interactive. Right now you're unable to ask questions, you're asking questions but not from the audio. In the live program, because we'll be having a limited 20 guys or 25 seats, so you'll be asking a lot of questions by unmuting yourself. But then when the next batch happens, you can come back again and again and again for next 1 year, so that you learn something 80%, and then second time you will learn 90%, third time you learn 95%, and anything new, any new questions come, you can come back again. Also, there'll be weekly live interactive sessions. Like today, right now, you can't ask question, or so I'm saying via the audio, but next time it will be the interactive sessions. Apart from that, there'll be videos and activity guide, so that you can learn at your own pace. The recording will be available on the portal for you, so that for example, you miss a session, you can watch the recording, or for some reason if you can't join that particular day's session, you can come back and listen to the recording again. Also, the big part is community. As I said, we learn in group, we learn when we are being made accountable, we learn when we see other people are making progress. And I have hundreds of success stories, and you will see that in a minute, where people are taking action because they see someone else have taken action. They take action because someone else got certified, so they, all the other guys, those who are ahead, they pull the guys behind them. And this is where WhatsApp group and ticketing system comes into handy. You have the recording, which will be for lifetime access, you can come back again and again. You have a lot of guys who are part of my other programs, you also will be part of this, so you know the pattern and you know the method we do. Also, it's covered by hands-on guides, so these are all step-by-step guides. You'll be getting all those 33 guides that we talk. And we focus on two things: job and certification. So people are asking how long this session is, or how much duration will be. We, whatever duration will cover, but our promise is we don't count number of hours. What we count is, have you got result? Will you were you able to become certified Kubernetes administrator? Were you able to get a job? Were you able to recover your cost, not only the cost of this program, but also earn a lot more higher? That's what you should be looking for. So next time when you go to any institute, ask for what results. Of course, we'll cover the whatever it takes. So we'll to deliver and learn. So we'll not leave you until you've learned and perfected and you said, yes, I'm happy with this. So that's our guarantee for you. So this is, as I said, it's this is how the portal will look like. We will be, you'll be getting the program. on with this all the modules I've covered already. So it's comprehensive. You don't need to do anything extra. You don't need any extra knowledge of programming or coding. Will cover all this for you. So there's no coding required. There's no development required. This is all for architects. So session, we're going to run it every Saturday and Sunday. Why Saturday and Sunday? Because most of the guys who come, they're working. It's comprehensive program. It'll need a lot of hands-on. So we do 4 hours each day. And then during the weekday, you ask questions. You have any problems, you practice the homework that being given to you during the weekday. So every Saturday, Sunday, 7 to 11. Now, some guys are um, there are a lot of questions will come, or if you have any questions related to timing, let me know. So it's morning US morning hours, 7 to 11 PST, 10 to 2 EST. In UK time zone, it's 3 to 7, or I think 2 to 5 or 2 to 6 GMT, and 7:30 to 11:30 PST in the evening for IST or India time. Now, as I said, you get 1 year on-job support. You get unlimited retake for the next 1 year. You get live interactive sessions. You get lifetime access to the videos and hands-on lab activity guide. Any lab changes will update, and you will get the updated guide with that. You will be part of 24/7 WhatsApp group. Now this is like the WhatsApp group look like. Now questions, if someone says if someone need any help, like you will, as I said earlier, the others will share their results or success stories that will inspire others to do. Like for example, I've cleared my architect certification, or I'm started on cloud. The way okay, I think this is more about talking about the teaching style. Probably I don't need to cover now. You've already seen Mamta on the way she teaches things, so that's not an issue at all. Now, the top support ticketing system, as I said, we have a ticketing system where you can, if you hit any problem which is taking longer, we also have a ticketing system so we can make us accountable and we can track progress on your issues. Now, we have around 60,000 plus subscribers, out of which 4,500 are paid members. So you're not the first one to join these programs or trainings. We have been doing it for 2007. We started officially programmatically on 2015. So it's almost 5 years now. We've been doing 5,500 paid members in various courses. These are some of the students. They talk about our support. Some of you guys who are new, um, I would just like to say the focus on course material provided by K21. And this is the repeat pattern we say. We make our program so good in terms of quality that you don't need to go anywhere else. Everything will be covered here. I've just cleared my exam, or think, okay, I think I've attended the live sessions for first